A-OK on board. We're right where we should be. You saw during that film that we had acquisition of the ship downrange tracking station. Now we have a different trajectory tonight than we have for our normal standard GTO missions.
Yes, for a GTO mission we must get as close as possible to the equator plane, which usually means an orbit of 6 degrees or less inclination. Tonight we shall release the ATV.
The DDO has just called out the extinction of the lower stage, the separation of the lower stage, and we should be hearing him call out the ignition of the upper stage. And there it is. We've ignited the upper stage. Those 3 commands given by the onboard computer that's flying on the composite still with the ATV in about 12 seconds each. There's the lower stage being dropped back into the Atlantic.
Coming back to the orbits, we have an inclined 52 degrees orbit for the ATV. And from Kourou we can perform launches to reach orbits with inclination from around 90 degrees for heliosynchronous orbits, then to 6 to 2 degrees for GTO orbits. As you can see, Kourou offers a wide variety of orbits and missions, including escape missions for interplanetary journeys like we did for Rosetta.
We're into the upper stage burn now. Before we start focusing on the ATV in the second half of the mission, we just want to take a look at the role of tonight's version of the upper stage, the ES.
So the EPS, that was a perfect ignition of the upper stage for a first burn of approximately 8 minutes. This stage is made in Bremen by our German partners of ELS Astrium. Greetings to them. We might say that the EPS today has 2 missions. One, to provide necessary velocity to deliver the ATV on the proper orbit before separation. But secondly, to realize an atmospheric re-entry in order to free the low orbit region above the Earth, avoiding to remain as a particularly dangerous debris for other launchers or manned vehicles flying to the station.
The speed, as you can see, 7 kilometers per second on the lower left of your screen. The speed we need to separate the ATV is a little over 8.
Little over 8. We will not still there, but we are right on track. We are right on the prediction of the trajectory.
So keep your eyes on the speed there, and when you see 8 kilometers, you know we're approaching separation. We can start focusing on the ATV now, a series of films coming up. Here's the first from the European Space Agency on the ATV's role as a cargo ship.
In the years to come, the ATV will become one of the principal vehicles servicing the International Space Station with unprecedented capacities and capabilities. At over 19 tons, the heaviest payload ever placed under an Ariane fairing, the space truck is 10.3 meters long, with a diameter of 4.5 meters. That's about the size of a London double-decker bus. The launch campaign saw the final assembly of this spacecraft's 2 main parts, the service module with the avionics and propulsion systems, and the pressurized cargo carrier with its docking port. Provided by Thales Alenia Space in Italy, the pressurized section offers 22 cubic meters, about half the volume of ESA's Columbus laboratory. It carries up to 8 standard-sized racks which can contain in closed bags a variety of supplies and instruments. 180 kilos of European cargo was first packed in Italy before the ATV was conveyed to Kourou. There, before the remaining cargo was loaded, the entire pressurized section was disinfected as a sanitary precaution. Supplies, some 1,200 kilos, mainly from NASA, were then stored on board, including 500 kilos of food, 80 of clothing and spare parts. The vehicle also carries several tanks which store drinkable water, oxygen and nitrogen, and fuel for the propulsion systems of the space station. The ATV can deliver water in compliance with NASA or Russian norms. For this first mission, 280 liters of drinking water from Turin, treated according to Russian standards. After further sanitary inspections, the hatch was closed, the ATV was purged and filled with pure synthesized air. Fueling the ATV under stringent safety conditions will have taken more than a month. It carries more propellants, over 6 tons, than the largest commercial satellites. Russian fuel and oxidizer were first pumped into 2 large reservoirs to be transferred to the space station through pipes in the docking mechanism. The largest quantity of propellant, however, was placed in the tanks of the service module, 3.5 tons for the ATV's own propulsion system, and when docked, to control the station's attitude and orbit. Because the ATV is also the most powerful space tug ever built, its 4 main engines and 24 small thrusters will be used to change the orbit of the complex, for eventual maneuvers to avoid space debris, and to periodically raise the orbit, countering the effects of atmospheric drag. When considering the bottom line of the manifest, dry and liquid cargo, propellants, supplies and equipment, the ATV will in fact be transporting 3 times more than Russian Progress vehicles, which to date have been servicing the ISS. Remaining attached to the space station for up to 6 months, the spacecraft's cargo section will be an integral part of the orbital outpost. Astronauts will be able to access it without spacesuits, to unload supplies, to store others, to place waste material to be discarded, and even to use it as rest quarters. Resupply, reboost, and an ultimate function, a fiery furnace for space refuse. After undocking, the vehicle will be targeted for controlled, destructive re-entry over the Pacific Ocean. The ATV's first mission unites past, present and future. It carries manuscripts by the French visionary novelist Jules Verne, and amongst the gifts for the ISS crew is a luxury 19th century edition of his work, From the Earth to the Moon.
From the Earth to the Moon and from the Earth to the International Space Station in the Ariane 5 ES version. Now, the ES version went through a series of upgrades for tonight's launch.
Since first launch in 1996, the Ariane 5 has evolved from the GEOS generic version to ECA version, cryogenic version, which is today the standard configuration like Ariane 4 was. The ES version has been specially developed for the ATV mission. The core stage and the booster are absolutely identical to the Ariane 5 ECA version, and the upper stage EPS is the same that equipped the generic version. The reignition capability of the EPS was, of course, the reason for this choice.
So we can say that we combined some of the proven elements from the earlier
We combined very well proven elements, absolutely, to build up this version of ES.
Like the main cryogenic stage, which remained the same for the ES version. There was some new flight software that had to be defined for this longer mission tonight.
Yes, and some reinforcements of the upper structures in order to cope with the very heavy weight of the payload.
Right, the carbon fiber in the vehicle equipment bay, which we keep talking about because that's where the computers are located, that had to be strengthened. Also, the attitude control system had to be adapted for the longer flight tonight.
Yes, we have on board 6 tanks of 37 kilograms of hydrazine for the attitude control system, whereas we usually have 3 or 4 tanks for GTO missions.
Now, these upgrades, I assume, were coming out of the benefits of all the archives. Ariane 5 been flying for about 10 years now, so there's a lot of material that you could use from. We just had the DDO calling out extinction of the upper stage, so we're at the end of our first phase of the mission into now what we call the coasting phase, the ballistic phase.
The ballistic phase has started upon the shutdown of the EPS,
and that should be going for about 45 minutes.
This will be going for 45 minutes before the second ignition of the EPS.
That's some of the new things going on for the flight tonight. We're going to go